Scientists just detected a biosignature on exoplanet K2-18b, stronger and clearer than anything we have seen before. You have probably heard the cautious chorus already. It is only 3 sigma. This does not prove aliens exist. We need more research. It could still be non-biological. But here is what they are not saying out loud. Behind closed doors, scientists are quietly freaking out, because this is genuinely the best sign of extraterrestrial life we have ever had. So, what exactly did they spot in that far-off sky? And why is it lighting up the rumor mill harder than Venus phosphine or Mars methane ever did? Buckle up. We are heading 124 light-years toward a red dwarf in Leo, chasing a planet that may be half ocean, half gas, and entirely history-making. First, the headline signal. Dimethyl sulfide, DMS for short. On Earth, almost every whiff of this funky sulfur smell comes from living microbes, especially plankton partying in our oceans. With the James Webb Space Telescope, researchers found DMS, or its close cousin DMDS, hovering above K2-18b at a concentration of roughly 10 parts per million. Pause and taste that number. That is thousands of times thicker than Earth's own biological fog. 3 sigma means the odds of pure random noise are about 0.3%, not rock solid, yet strong enough to raise every eyebrow at the conference bar. The team only needs roughly 1 extra day of web time, 16 to 24 hours, to push that to the 5 sigma gold line. 5 sigma is 1 chance in roughly 1.7 million. Las Vegas would laugh at those odds. Now, why is this stronger than our past flings with possible life signs? Venus gave us phosphine, but the data wobble was messy. The atmosphere is a sulfuric acid pressure cooker, and follow-up tore the claim apart within months. Mars keeps burping methane, yet the amounts are trace, the detections conflict, and geology can make methane the boring way. K2-18b is different. 1. The signal repeats in 2 independent Webb instruments and 2 different infrared bands. 2. It sits inside a cocktail. Methane is abundant. Carbon dioxide is abundant. Ammonia is suspiciously scarce. That perfectly matches the model of a Hycean world. Hycean means a global ocean beneath a hydrogen sky, warm enough for liquid water, shielded enough for chemistry to simmer. Picture that for a second. A murky green sea stretching around the globe, whipped by constant winds under a dim coral sunset. Microscopic life blooms, exhaling DMS into the thick air until the gas builds up to levels we can spot from halfway across the galaxy. That image is what keeps astronomers up at night, grinning like kids who found cookies before dinner. Of course, the skeptic inside us asks, could geology fake this? Maybe. Recent lab work shows you can spark a little DMS by zapping hydrogen sulfide and methane with ultraviolet light. Comets carry it too. So the real test becomes abundance. Can non-life crank out 10 parts per million in a hydrogen bath without an ocean full of critters? Right now, nobody's model pulls that rabbit from the hat. But science loves surprises, so the burden is on the life lovers to prove the negative pathways fail. There is also the elephant in the observatory. Habitability. At 2.6 Earth radii and 8.5 Earth masses, K2-18b teeters on the border between super-Earth and mini-Neptune. Skeptics like Raymond Pierre Humbert argue it could be a steamy hell, more lava world than lagoon. No direct water vapor signature has popped yet, but the missing ammonia, plus the methane to carbon dioxide ratio, still whisper that an ocean might lurk beneath the clouds. If so, surface pressure could be dozens of bars. Deep, yes, yet within the comfort zone for hardy microbes. After all, Earth's hydrothermal vents brim with life at even higher pressures. Let us zoom out to psychology for a moment. Why the public caution? Careers, credibility, and the memory of past flops. Declare aliens too early, and your reputation sinks faster than a lead rock. Huge telescopes cost billions. Funding panels hate hype hangovers. So researchers use phrases like tantalizing hint, intriguing possibility, consistent with, and everyone else hears maybe. Behind the scenes, though, Slack channels explode with all-caps expletives of joy. That duality, cool press quotes, hot private chats, is exactly what you would expect when the biggest question ever dangles at arm's length. Let us play the numbers game. How could the detection get stronger? More transits equal better signal to noise. Stack 2 or 3 more and you leap from evidence to discovery. Splitting DMS from DMDS would also sharpen the blade. Higher resolution or a different wavelength window could do it. If Webb cannot manage, Europe's extremely large telescope might jump in before decade's end. And farther out, NASA's Habitable Worlds Observatory aims to image Earth-sized planets directly, but that is future talk. For K2-18b, Webb is our best shot now, and it is biting. Suppose 5 sigma lands and abiotic roots strike out. What then? We will still be talking microbes, not Martian baristas beaming hello. Yet microbes alone shatter the cosmic loneliness we have carried for centuries. And here is the spicy twist nobody dares say loud. If a planet can breed bacteria under a hydrogen sky, evolution is free to march. Nothing in physics blocks those microbes from getting smarter over geological time. They could build mats, colonies, maybe complex multicell forms, maybe senses, maybe cognition. Intelligence is not guaranteed, but the door stands open. The universe suddenly feels less empty, more alive, more unpredictable. Let us not forget the distance. Even at warp fantasy, 124 light-years is a haul. We will not send probes soon, so remote sensing is all we have. Does that doom us to eternal doubt? Maybe not. Confirmation in science is rarely one bullet. It is a quilt of independent clues. 5 sigma, DMS. Seasonal variations matching biological cycles. Complementary gases like nitrous oxide or even trace oxygen. Each patch stitches a stronger story until skepticism collapses under its own weight. Meanwhile, the public narrative risks swinging too far the other way. Some pundits already shout, "Calm down, it is just bacteria at best." But that phrase hides a faulty premise, that single-celled life is trivial. Life in any form rewrites textbooks, theology, and our self-image. Microbes terraformed Earth long before dinosaurs painted the scene. Given time, simple can become spectacular. Real talk. Will we ever reach a bigger smoking gun than this? Maybe not soon. Most habitable candidates are smaller, dimmer, or shrouded in glare from sun-like stars. K2-18b sits in a sweet spot, large enough for a puffy atmosphere we can read, yet parked in a zone that might keep water liquid. If DMS at 5 sigma cannot clinch excitement, what can? Sometimes good enough has to be good enough to celebrate. So where does that leave us? Waiting on telescope time, running lab experiments in pressure vessels, arguing over chemical networks at 3 a.m. on Slack, and quietly, collectively, hoping that the universe has decided to whisper yes. Before we wrap, let me yank the curtain back to you. Imagine waking tomorrow to the headline, "Official, Life Confirmed on K2-18b." How would your worldview shift? Would ancient myths feel less lonely? Would future space policy jump toward interstellar probes? Would you look at Earth's oceans with renewed awe, knowing they are no longer unique? Hold that thought, because whether this signal proves life or not, it drags humanity one giant step toward an answer. Either we confirm a cosmic neighbor, or we learn more about the wild chemistry planets can cook without biology. Both outcomes push the frontier. Stay tuned. Webb's next peak could land sooner than you expect. And when it does, we will be right here, turning the data into stories.